Well, hello, Algebra 2 class. Sorry that we're not able to get together in person this week, but we are going to do the next best thing we can to that. Hopefully these videos will be helpful to you. One good thing about them is you will be able to replay them as much as you need to. If there's something that doesn't make sense, you can just kind of scrub backward and watch that part again. And if it still doesn't make sense to you, again, you can read the book or you can reach out to me. And if we need to set up a Zoom call or something like that, I'm more than happy to help in that way as well. But otherwise, I'm thinking that you're going to not have too much trouble with the rest of this chapter. So we're going to be kind of working through the rest of chapter 6 this week. We're going to do 6.5 today, 6.6 tomorrow, 6.7 the next day, 6.8. And then I'll kind of give you a break. So just 4 days of work this week. And then next week, we'll do some review work and take a test sometime in the middle of next week. So we're going to be talking today about dividing polynomials. So just as a warm-up exercise, if I gave you this little thing, 51x to the fifth y squared over 34x y cubed, and asked you to divide this, what would you go about doing? Well, you would first look at the 51 and 34 and say, is there anything that goes into those two things? And I think you, after some amount of contemplation, you would realize, oh yeah, 17 goes into both of those. It goes into 51 3 times, and it goes into 34 2 times. You would then take this x to the fifth, and you'd have below it x to the first. Remember, when you have a division of exponents, you subtract them. So it'd be 5 minus 1, so you get x to the fourth on the top. And in the next case, you'd have y to the second over y to the third. Well, the third beats out the second. You'd subtract the 2 from the 3 and leave it on the bottom, so it'd be a y on the bottom. So it would look like this, 3x to the fourth over 2y. Well, what about just, again, this is going back some time ago. Certainly you've done problems like these before. But let's say you have 1335 divided by 15, and I asked you to do it by long division. Well, you would write this 1335 underneath the divisor here, and you'd have 15 out here. And then you'd ask, how many times does 15 go into? Well, we know it doesn't go into 13, so we have to go to 133. How many times does 15 go into 133? And again, after some contemplation, you might come up with an answer like 8. 8 times 5 would be 40. 4 plus 8 would be 12. So we get this. We'd subtract that then from 133, and we get 135. And then we just have to ask, how many times does 15 go into 135? Well, again, we know that 8 did it to 120, so just one more, right? 9 times should be 135. It'd be 45. 9 times 5 is 45. 4 plus 9 is 13. We subtract that, and we get 0. And so our answer would be 89. In this other case, 5208 divided by 16. Let's think about that one together. So we have 5208 and divided by 16. So we have to think, how many times does 16 go into 52? 2 times would be 32. 3 times would be 848. So yeah, I think that would work. So we'll do, again, that'd be 3 times 6 is 18, plus 1 plus 3 would be 4. So we subtract 48 from 52, and we would get 4. Remember, we bring down the 0 from this place. We bring that down. So how many times does 16 go into 40? Well, it's not 3. It must be 2. So 2 times would be, what, 32? And that would leave us with a remainder of 8. And we bring down our 8 here. We get 88. And we have to ask, how many times does 16 go into 88? Well, 16 times 5 would be 50 plus 6 would be 80, right? So that's pretty close. So 80. So 88 minus 80 would be, again, we would be left with an 8. And notice we would call this a remainder of 8, right? So we'd have 325 with a remainder of 8, which is what the answer is. Okay, so just remember that. And now we're going to apply some of these principles to dividing polynomials. So to divide a polynomial by a monomial, all you do is you divide each term of the polynomial by the monomial. So in this case, if we had 3x squared y cubed plus 9x to the fifth yz squared minus x to the fourth yz to the fifth, all divided by 3xyz, all we need to do is, in each of these cases, take this divisor, divide that into each one of these separately. Make them into 3 separate divisions. And so in the first case, notice we just separate these out. In the first case, we just look at what is in common and see what we can cancel out. So here, in case the 3's can cancel. This x can cancel with one of these x's, leave us with a 1 on the top. These y's, we have 1 y down here, we have 3 up here, so let's make this a 2, and we'll leave the z on the bottom. In this case, we see that this becomes 3. 9 divided by 3 is 3. Again, this x can cancel one of these from the x's. The y's cancel each other, and this z will take one of these away. We'll left with 1. In this case, the 3 stays on the bottom. This x will take one of these away. These y's will cancel each other, and this z will make this into a 4th. And so each one of those done individually looks like that. Okay, but to divide a polynomial by another polynomial, we're going to use the long division algorithm that you used to use when you divided large numbers. So watch, we're just going to apply what we just did with that long division to the process of dividing a polynomial. So in example 2, we see this problem. Divide x cubed plus 4x squared plus x minus 6 by x squared plus x minus 2. So we just set it up as a long division problem. And all we have to do is we now look at the first term here, this x cubed, and we look at the first term in our polynomial outside here, and we ask, what do we have to multiply that x squared by in order to get to an x cubed? Obviously, what we need to do is multiply it by another x, right? If we multiply it by another x, we'll get the x cubed. So that's what we do. We multiply that by an x, and now what we're going to do is multiply this x by this entire thing. So x times x squared is going to be an x cubed. X times x will be x squared, and x times minus 2 will be negative 2x. And so we write each of those in turn. And now we subtract that entire thing. So notice here, that negative sign out here has to be distributed to each one of these terms when you do the subtraction, okay? So x cubed minus x cubed is just 0. 4x squared minus x squared is going to be 3x squared, and positive x minus a minus 2x. Notice minus a minus makes that a plus. So we should get 3x squared plus 3x. Okay, now at this point, we just ask the question, what in this problem here, by the way, we're going to bring down our negative 6. Sorry, almost forgot to say that. So this negative 6 is brought down just like we would in a long division problem. Now we ask again, what is it that we need to multiply this x squared by in order to get 3x squared? Well, it just needs a 3 out front, right? So all we have to do is put a plus 3. And now we're going to multiply this 3 times each and every one of these parts in this guy, and then write those all below here. So that becomes 3x squared plus 3x minus 6. And remember, we now subtract that whole quantity from what's above it. And when we do, notice that 3x squared cancels, the 3x minus 3x cancels, negative 6 plus 6 then cancels, and we get 0. So we now know from all of this, because the remainder is 0, that the divisor and the quotient are factors of the dividend. So both the divisor that we were dividing into that thing and the quotient, what we got out when we did the division, both must be factors of the dividend that we were dividing from. So in other words, this was the original thing, the dividend. We know that the divisor and the quotient, the answer we got after we got done with all of that, I'm sorry, this was the, I'm sorry, I said that different. This is the divisor and this was the quotient. That both of those are factors of the dividend because the remainder was 0. Well, let's look at this one. Determine whether x minus 2 is a factor of 3x cubed minus 8x squared plus 14. So we're just going to set up our problem as we did before. And now we're going to go about trying to solve this. So again, we just ask ourselves, what is it that we need to multiply this x by in order to get to a 3x cubed? Well, it's going to take, in this case, a 3x squared. 3x squared times x gives us a 3x cubed. 3x squared times the negative 2 right here, so multiplying these two together, we get negative 6x squared. Then remember, we subtract this entire thing from what's right above it. So 3x cubed minus 3x cubed is 0, but a negative 8 minus a minus 6 makes that a plus, right? So it becomes negative 8 plus 6, which is a negative 2x squared. Then we ask, what do we have to multiply this x by in order to get to a negative 2x squared? Well, obviously we need a negative 2x. We do bring down this. Note that we have to insert a plus 0x if it's not included, so we have to add that there just to have a placeholder, so we know that we have to think about that. So here we need a negative 2x. So now we're going to multiply this guy by both of these and write those answers down here. So negative 2x times x is negative 2x squared. We multiply this negative 2x by the negative 2, and we get a positive 4x. We then subtract all of that, remember? So this will go away, and we're left with a negative 4x, and then again we bring down our plus 14. Now we ask, what do we need from this x to make it into a negative 4x? Well, negative 4. We multiply negative 4 times x, we get negative 4x. We multiply the same number then by this negative 2, and we get a positive 8. We then subtract that whole thing. Remember, this negative gets distributed each time. This is the thing that can trip up students sometimes, but the negative is distributed to both of them. So this again falls out, but we're left here with a remainder in this case, which means since there's a remainder, this x minus 2 is not a factor of this because there was a remainder. If there's ever a remainder, you know it's not a factor. If there's no remainder, if the remainder is 0, then it is a factor. So the result of this division can be rewritten as, again, all of this stuff plus then the remainder, but being shown over the x minus 2. So that's the way that we end up showing the remainder, is we just put it over the divisor. When a polynomial is divided by a binomial of the form x minus a simpler algorithm called synthetic division can be used. Now, I know there's a lot of students that really do like synthetic division, so let me show you how this works. Now, the important thing to remember is it has to be that you're dividing by something that has the form of x minus a, where a is some constant, and x is the variable. So, in this case, notice that we're trying to divide this 3x cubed minus 8x squared plus 14 by x minus 2, which has the form of x minus a. Since it has that form, we can use this method of synthetic division. Now, how do you do it? Well, we begin by looking at this, and we say, what in this would make this factor into, if we set it equal to 0, what does x have to be in order to equal 0? In other words, it's going to be the opposite sign of whatever this value is. So if it's a negative 2, it's a 2. If this happened to be plus 2, it would be a negative 2. So we just put the opposite sign of whatever is on the a value here into this little box. And then we rewrite all of this part. We remove the x cubed, x squared, x, and all of that from it. But we put a placeholder for every spot from x cubed all the way down to the constant. So note here we write 3, negative 8, and we've added this 0 because there is implied here a plus 0x term that isn't shown. So we have to give space for it by writing a 0 and then 14 for the constant that's here at the end. So that's why this 0 got in here. Make sure you take note of that. It's because, notice we had the x to the cubed, x squared, but we had no x term, so we had to include a 0 for that place. If, for example, we had another problem where it was like 3x to the 4th plus 4, let's say, and that was what we were trying to divide into. Note what's missing here is the x cubed and the x squared and the x term. So we would have to rewrite that if we were doing synthetic division as 3, 0, 0, 0, and then the 4. So you have to include spaces for every one of the decreasing powers of x. So here we have 3, negative 8, 0, and 14. And here's our 2. So what we do is the first thing we do is we bring down that original 3. We just bring it straight down and right underneath the line here. Then we take that 3 and we multiply it. Here when we're showing this arrow, we multiply this 3 times the 2, and we get 6. And then we just add straight down. So negative 8 plus 6 is negative 2. And now since we have an arrow moving up, we're going to multiply this guy now by this times 2. It's always times the guy that's over here in this box. So negative 2 times 2 is negative 4. And then we add down. 0 minus 4 is just negative 4. Or I should say 0 plus a negative 4, right? Just adding down. negative 4. And then we multiply that by 2. And so because 2 times negative 4 is negative 8. And again, we just add straight down. 14 plus a negative 8 would leave us with a remainder of 6. So we do have a remainder of 6, which means that x minus 2 is not a factor of this polynomial because it had a remainder. If this instead of having a 6 here, if this was just a 0, then it would be a factor. But because it's not, because there's a remainder, it's not a factor. And we can rewrite then the rest of this is just negative 4, negative 2. We write the x there, and then a 3x squared. So we just start to increase the powers of x as we go from right to left here. Let's do another example. This is example 5, and we're using synthetic division to divide this number. Now notice, here we have, again, the same form of x plus c. But remember I told you what we're going to put into the box is going to be the opposite sign and value of whatever this part is over here. So we're going to put a negative 3 into the box here. Then what are we going to write up here on this top line? Remember, looking at these guys, the first one's definitely going to be a 1, but notice what's missing is the x squared term. So we have to put a 0 in for that term. Then we have a negative 7 for the x spot, and then a 6 over here for the constant. And now we do the same thing. Remember, we start by bringing down the 1. Then we multiply that 1 by the negative 3, whatever's in this box, and we get a negative 3. We add down, so 0 plus a negative 3 is just negative 3. Negative 3 times a negative 3 gives us a 9. We add down negative 7 plus 9 is a 2. 2 times negative 3 is a negative 6. And notice what happens here. When we add down here, we get a 0, which means our remainder is 0. Again, we can then work from right to left. This 2 is just the 2. This negative 3, we have to add the x. And then this 1, we have to put it to x squared. So x squared minus 3x plus 2 with a remainder of 0 means that this is a factor of x cubed minus 7x plus 6. But it also means that the original thing that we were dividing from with was x plus 3. That also is a factor of this x cubed minus 7x plus 6. And that's it for this lesson. You're going to get practice doing dividing by monomials. You're going to divide by long division. And then in the case where you have an x plus c dividing into something, you're going to use that synthetic division. Get some practice doing that. So your assignment is to do 6.5, numbers 2 through 32, 42 through 48 evens on pages 260 to 262. So anyway, hope that is helpful to you guys. Go ahead and watch through this again if you need it to be explained again. Also read the section 6.5 if that's helpful to you as well. And otherwise, I'll see you guys again tomorrow as we get into the next section, 6.6, and we'll be factoring polynomials together. Thanks so much, guys. God bless you.